Lesson number 9 looks at taking an algebraic approach to these types of questions. So how would you solve these without graphing them? So the key to solving these is looking at the standard form of the quadratic function. That's that y equals a times x minus p squared plus q. So in this section here, we're probably going to be completing the square for a lot of these questions in order to do the algebraic, or looking at the quadratic formula. Things to remember when I'm in standard form: what are the coordinates of the vertex? P and Q. Okay? When do I have a maximum value of the graph? So what is the general shape of the graph in order to have a maximum point? It has to open down. When does it open down? What do I look at? When a is negative. So when a is less than 0, what is the maximum value equal to? So what do I look at for the maximum value? What's that point? The vertex. But which part of the vertex do I look at? The x or the y? The y value, which would be q. Okay? And then when do I have a minimum value? When a is greater than 0. And what is the minimum value? It's still q. And what is the equation of the axis of symmetry? P. X is equal to P because it's an equation. Good. So if we look at the class example from the last lesson on the projectile, that negative 4t squared plus 48t plus 3. If we were to complete this algebraically, the first thing that we would probably want to do is we'd want to write this into standard form. So we need to take this and complete the square. So what is the first step I need to take in order to complete the square?
You have to factor out a 4 first.
Okay, positive or negative?
Negative.
So if I take out a negative 4, what am I left with?
T squared plus 20.
T squared
Oh.
minus 12t,
Oh,
right? And then I don't take the 4 out of the 3, though. So how do I go about completing the square at this point?
You take half of negative 12 and square it.
What's half of 12?
6
Squared.
is 36.
So I add 36 and subtract 36 to keep my 0. Now what would I do?
Would be T plus minus 6 squared. I forgot what I was saying.
And what happens to the negative 36?
You have to times it by 4.
Multiplied by the negative 4, though. And what is negative 36 times negative 4? Pardon?
144.
And then add the 3.
147.
So there is my equation in standard form. So if I look at question B, find the height of the projectile 3 seconds after the launch. I can put 3 into this formula. And solve for height. So 3 minus 6 is a negative 3 squared. 9 times negative 4.
Negative 36.
So I now have negative 36 plus 147 equals what? And that's what we got in the last section. It was 111 meters after 3 seconds. What's the maximum height reached by the projectile? 147. How did you get that, Evan?
Because it's Q.
Because it's the Q value. How many seconds after the launch was the maximum value reached? So when did I reach 147 meters?
At 6 seconds.
At 6 seconds. It's the P value. Question E, what was the height of the projectile at the launch? What happens at the launch? What's the time? 0. So I'd be finding h of 0. Which formula do I want to use to find h of 0? The general or the standard? Look at the general. This is the general. So the top one is the general, this one's the standard. So this one would be the one I'd want to use when t is equal to 0, because these two terms are gone, leaves me with 3. So at the time of the launch, the projectile was 3 meters in the air. And then question F says, determine when the projectile hits the ground to the nearest tenth of a meter. So when it hits the ground, the height is going to be 0. So it would be solving this equation. So how would I solve that equation?
Subtract 147.
Okay, and then what else would I do?
Divide it by negative.
So I'd get 147 over 4 equals t minus 6 squared. Then what would you do? And I could get the plus or minus. And then to get t by itself, I would add 6. So t would equal 6 plus or minus the square root of 147 over 4. And what would that be to the nearest tenth? Would you get, Bobby M?
12.06.
So to the nearest tenth would be 12 point.
1.
And what else do you get?
It's 0.06. So,
Positive or negative?
0.1.
So which one would I reject? Which one wouldn't I use?
A negative.
The negative. This one would be canceled out because I can't have a negative time. These answers were the same as what we got in the first case. Is there another way I could find out F? Instead of completing the square, what else could I have used? I could have used the quadratic formula, and if I used the quadratic formula, I would have used these numbers here. So then I would have gotten negative 48 plus or minus 48 squared minus 4ac all over 2a. Okay, the next question. A rancher has 300 meters of fencing with which to form a rectangular corral. And in case you don't know what a corral is, it's basically an enclosure used to keep livestock. One of the sides is an existing wall, so I don't need fencing. So I have a wall. And then I'm going to create a fence using that wall. If the two sides of the fence are each x meters in length, show the area can be expressed in the form 300x minus 2x squared. How would I figure out the length of this rectangle?
The area divided by
But do I know what the area is? Pretend I don't know this. Okay, this is covered up. I don't know what the area is. What information do I know? What do you know about the fence?
We know that it's rancher has 300 meters of fence.
So that means this side plus this side plus this side has to equal 300. So if I know what these two sides are, how do I find this one? 300 minus 2x. Now if I look at area being length times width, I get 300 minus 2x times x, which when I multiply it through, gives me my 300x minus 2x squared. There's my area. Part B says use the method of completing the square to determine the maximum area possible. So if I want to complete the square, what would I start off by doing? Would it be better if I wrote the equation like that? So I'd write the equation so that it was in descending order. And then what would be my first step in completing the square? So then I get x squared and then what? And what would be my next step?
Take half of 150,
Yes?
which is 75, and square it, which is 5,625.
And then I would have to subtract to keep it at 0. And what would be my next step?
And factor the trinomial.
Okay, so when I factor the trinomial, what do I get? X minus 75. And then I take out that 5,625, and what do I do with it? Multiply it by -2. So then I get -2 times x minus 75 squared plus what?
11,250.
What does the 11,250 represent? In my standard form, this is q. What does q represent in the quadratic? The min or the max. Is this a min or a max? Oh, it's a max. So this gives me the max, which is my vertical axis. What am I measuring along my vertical axis? What am I measuring? Area. So this gives me my maximum area. What does this give me? This is the p-value, which is my x's. And what does x give me? The width. So the maximum area, would be 11,250 square meters. So what would be the dimensions of that rectangle? The width we've already determined would be 75. And what would the length equal? How did you get that?
When you multiply the width by 2, then you get 150. So 300 times 150.
Is there another way I could get 150? If I know the area and the width?
You could go divide the area by the width.
Yeah, and you would still get 150. We're not going to get time to do this one. We'll wait. We'll finish it tomorrow.
I would have to.
Question number 3 from lesson 9 says Ashley is asked by her math teacher to find two numbers who differ by 8 and whose product is a minimum. Whenever you see questions that imply or are asking for a minimum or a maximum, like the ticket question that asked for the maximum revenue or the maximum ticket price to get that revenue, or the maximum width that you can have to get a maximum area, you're setting up a quadratic, because to get that max or that min, you need to have that parabola. You need to have a low point or a high point. So if x represents the smaller number, write a quadratic expression for the product of the two numbers. So if x is the smaller number, and the two numbers differ by 8, what's the larger number? X plus 8, good. So then to write a quadratic expression in terms of x for the product of the two numbers, we could write it in the form of p of x, the product of x. Would be x times x plus 8, which would give me x squared plus 8x. Now again, remember we are solving this one algebraically. If we weren't asked to solve it algebraically, if this was a multiple choice question or a numerical response, I could use my calculator and I could graph it and I could find my answer through my graph. But if I was to do this algebraically, I'm going to complete the square. So how do I complete the square with x squared plus 8x? What would I do?
You divide 8 by 2 and then square it, so you get 16.
So then I
Add 16 and subtract 16.
good. And then my next step would be to do what?
Factor the trinomial.
And what do I get when I factor that trinomial?
X squared or x plus 4.
So what do the numbers 4 and negative 16 represent?
Wasn't
Where would I find them on the graph?
a negative 16 is here.
So if I go back to my standard equation, that a times x minus p squared plus q, what do p and q represent on my graph? The vertex. So in this case here, what's my vertex?
4 and negative 16.
Got the negative
Isn't
16.
it negative 4?
It would be a negative 4. So remember, it has to be written as an x minus. So then if I was to think of a quick sketch, it's a minimum because it opens up. So I get a graph that's like this, where this point here is at negative 4 and negative 16.
So then this negative 16 is your minimum product.
Exactly. So the minimum product is negative 16. And what is the x value that gives me that minimum product? So when is it negative 16? At negative 4. So the smaller number is negative 4. And what's the larger number? 4. These two numbers differ by 8, and their product is negative 16. So question number 3, and then question 6 to 9.